Hi there! We're going to continue working with Chapter 8, Quadratic Equations, Inequalities, and Functions. We have been working with the square root property, so we are going to continue with completing the square. Two things we're going to learn in this video: solving quadratic equations of standard form, ax squared plus bx plus c equals 0, by completing the square. One, when the leading coefficient a is 1 and when it is not 1. We're also going to solve quadratic equations with solutions that are not real numbers. Since we've been studying imaginary numbers, we're going to see them show up in this section. First, let's start by thinking about what must be added to x squared plus 4x to complete the square. So what does complete the square even mean? What I want you to do is to think of x squared as a square of length x. As a visual person, I find this very helpful. So there's a square of length x, which means its area is x squared. And I want you to think of 4x as x plus x plus x plus x. So that means we're going to have 4 smaller rectangles, since they're not squares, of at length x by 1. So I have 4 of those, which gives me our x squared is the big x squared, and 4x is made up by those individual x by 1 rectangles, 4 of them. So I want you to think about how would you arrange the 4x pieces with the big x squared to make a square again. So you can pause the video, think about what that will look like. So how can you take these 4 smaller pieces and arrange them with the big piece to try to keep it a square? After you have thought about it, you can unpause. You may have thought to arrange them around the square like this. This is only one way, there are other ways. But this doesn't quite make a square again. There's a part missing. You notice this corner is missing. So how much is that? How much is missing? Fill in the missing part to see. The orange part there is what's missing, which is 4. Notice that since this is 1, 1, 1, and 1, it creates a 1 by 1 smaller squares, and there's 4 of them. So 4 is what must be added to complete the square. The completed square for x squared plus 4x is quantity x plus 2 squared. Since our original square of length x was altered, we added 2 on each side. Remember, a square is a quadrilateral with all 4 sides the same. So this sides have now length x plus 2. So that's our square. Now, how would you figure out what must be added to complete the square for x squared plus 6x? In this one, it was 4x, so we had 2 and 2. What would you do for 6x? Go ahead and pause the video if you like and think about what that would look like. Following the previous example, we will arrange similarly. So x squared plus 6x, I'm going to do the 6, I'm going to split them up into 3 and 3 along the big x squared. And the missing part is going to be filled in by 1 little squares. And how many of those are there? The missing piece is a 3 by 3, which means 9 little squares. And that completes the square. So in general, what does completing the square mean? The process of completing the square is we take half the coefficient of the first degree term. So the 6x is the first degree term, right? That's the quadratic term. First degree is just the x. Coefficient is 6. Take half of that. That's what gives us the 3. And then we square it. The result is what must be added to complete the square. Since we get a little square of 3 by 3, that's what must be added. So in this case, we add 9. The completed square is, so how has our size changed? It went from x to x plus 3 and x plus 3. So the completed square is x plus 3 squared. Now let's try this in solving equations. How do we solve an equation by completing the square? Notice that for completing the square, we only needed the quadratic term and the first degree term. We don't need the constant term, so we're going to move it to the other side. So add 10 to both sides. And now we're going to complete the square. Now remember, for completing the square, we take half of the first degree term, so half of minus 2, and we square it. So half of minus 2 is minus 1. Square it, you get 1. So we're going to add 1 to each side of the equation to balance it. And now that trinomial, we want to factor it into a perfect square again. That will be x minus 1 squared. And on the right side, just combine. 10 plus 1 is 11. Now we're going to use the square root property, which we learned before. So take the square root of both sides. Remember, when you take the square root, you get plus or minus. So we have x minus 1 equals the square root of 11, or x minus 1 is the negative square root of 11. And then solve for x. So add 1 to both sides. So our solution set is 1 plus or minus the square root of 11. Now on your own, try to solve this one. X squared minus 6x plus 10 equals 0. So go ahead and grab your notebook and solve this problem. Pause the video until you have solved it completely. Now that you're back, let's see how we solve it. So again, we're going to move the constant term to the other side since we don't need it for completing the square. And now we're going to take the minus 6, right? That's the coefficient of the first degree term. Take half of that and square it. So half of negative 6 is negative 3. When you square that, you get 9. So that's what must be added to each side to complete the square. And the trinomial, let's factor it into a perfect square. Which perfect square? X minus 3 squared. And minus 10 plus 9 is negative 1. And now use the square root property again. Square root of both sides. So you get plus or minus the square root of negative 1. Now remember, square root of negatives we can't do, but that's where imaginary numbers come in. And the square root of negative 1 is actually I. So when we add 3 to both sides, we get 3 plus I or 3 minus I. So the solution set, you should have gotten 3 plus or minus I. So let's put it all together. In general, solving a quadratic equation by completing the square, we have to first be sure that the second degree term has a coefficient of 1. So our leading coefficient has to be 1, the A. If it's already 1, then go on to step 2. If it is not 1, but some other number, so if this A, x squared, if the A is something other than 1, we're going to have to divide each side of the equation by that coefficient. Step 2, we write the equation in the correct form, meaning the constant term is on the other side. Then step 3 is we complete the square. And remember, completing the square is we take half the coefficient of the first degree term and square it. And we add that to both sides of the equation. We factor the variable side, which should be a perfect square trinomial. And we combine terms on the other side. Step 4 is solve the equation using the square root property. So let's try an example where the leading coefficient is not 1. So notice that the leading coefficient is a 3. So A is 3. So we're going to divide each term by 3. So here we go. When I divide each term by 3, I get a 1. 6 divided by 3 is 2. And negative 2 divided by 3 is just 2/3. Leave it as a fraction. We don't want to introduce decimals, especially when you're divided by 3, because that would be not a pretty decimal. And then write it in the correct form. So move the constant term to the other side. And now we're ready to complete the square. Take half of 2 and square it. So we get 1. And that's what we're going to add to both sides of the equation. Now we have this trinomial, x squared plus 2x plus 1, that we want to factor into a perfect square. And combine on the other side. Use the square root property. So take the square root of both sides at this point. Don't forget the plus or minus. And in this case, let's solve them individually. So I have x plus 1 equals the square root of 5/3. We're gonna subtract 1 from both sides. And we need to combine them somehow. So we're gonna want to rationalize this square root. So go ahead and use the properties of radicals to write it as the square root of 5 over the square root of 3 and rationalize. So we will get the square root of 15 over 3. And now let's get a common denominator, which is -1 and that square root. And common denominator is 3, so we get -3 plus the square root of 15 over 3. Same process on the other side. It's just that we have a negative radical there, but they will look pretty much the same. And that's our solution set. Email me if you have any questions on this video or if something didn't make sense. I hope you took notes, but you can, of course, always rewatch the video when something needs clarification.